Hello and welcome back. Today we're going to be talking about how to multiply and divide rational expressions, or fractions. The objectives today are going to review how to multiply and divide fractions. We're going to find the factors of a rational expression and reduce. And the third objective is we're going to multiply and divide rational expressions. Alright, we're on to our first objective. We're going to review how to multiply and divide fractions. The first fraction, you've got a little star symbol in between, which means that we're going to multiply. And to multiply fractions, you multiply the tops to the tops and the bottoms to the bottoms, giving us 12 over 18. Then you have to reduce your answer. To reduce your answer, you find a common factor for the top and the bottom. Both the top and the bottom are divisible by 6, leaving us with 2 over 3 as our reduced answer for that first fraction. We're going to take a look at the second fraction. We have 3 times 6 over, or 3 over 5 divided by 6 over 15. To divide a fraction, you always have to flip the second fraction. So I go 3 over 5 times 15 over 6. And then I just multiply the tops to tops and bottoms to bottoms. So again, the way I did that is I flipped the second fraction upside down, giving me 45 over 30. Then you look for a common factor both in top and bottom, and you notice you can divide them by 15. This gives us 3 over 2. And there you go. That's just a real quick review on how to multiply and divide fractions. Okay, we're on to our second objective, which is to find the factors of a rational expression and then to reduce. Before we can do that, we need to talk about what a factor really is. The word factor indicates multiplication. Let me give you an example. 2 and 4 are factors of 8 because 2 times 4 equals 8. For variables, 2 and x are factors of 2x because 2 times x equals 2x. Well, let's use this idea and please list the factors of 3y, z. The factors of 3yz are 3, y, and z. The reason 3, y, and z are factors of 3yz is because 3 times y times z gives me 3yz. But what about x plus 2? What are the factors of x plus 2? Looking at it, do you see any multiplication for x plus 2? I don't. So the only factors of x plus 2 are x plus 2 and 1. Because 1 times x plus 2 is x plus 2. This is going to be important later on. We're going to take this idea and we're going to identify what common factors are here in a second, and then we'll be able to fully factor rational expression and reduce. Okay, we're still on our second objective, and we just got a few more vocabulary terms to define. First one is the word common factors. Common factors are factors that are the same for two expressions. The second thing we need to define is how to reduce. To reduce a fraction, we divide by a common factor of the numerator and denominator. In other words, we just cancel out factors that are the same on the top and the bottom. For example, reduce the following fraction, 12 over 20. Although we wouldn't normally do this, this is going to be useful for our future problems. I'm going to rewrite 12 and 20 using their common factors. 12 can be written as 4 times 3, and 20 can be written as 4 times 5. So to reduce, we could either divide the top and bottom by 4, thereby canceling out the 4's, or we can just go ahead and cancel out the common factor, top and bottom, leaving us with 3 over 5. Okay, using those two concepts from before, let's go ahead and look at our first example of actually finding the factors of a rational expression and reducing. Looking at this rational expression, we notice that we can factor the top, and that's what it means by find the factors of. To factor the top, we notice we have 1, 2, 3 terms, so we're looking for two numbers that multiply to -8 and add to -2. Those numbers are 2 and -4, so our factors are x plus 2 and x minus 4. Of the denominator, when we factor the denominator, we get x plus 2 and x minus 3. Now, if we look at the instructions, they tell us to find the factors and then to reduce. Remembering what it means to reduce, we can just cancel out factors that are the same in the top and the bottom. We see that on top we have an x plus 2 in parentheses, and on the bottom we have an x plus 2 in parentheses. This leaves us with x minus 4 over x minus 3. My question to you at this point is, can you cross out or cancel out any like factors of the top and bottom of x minus 4 over x minus 3? The answer is no. We cannot reduce further. The reason we cannot reduce is because x minus 4, that entire expression, because it's the entire numerator, has no factors other than 1. Same way with x minus 3. It has no other factors other than x minus 3 and 1. So that means there are no common factors to cross out. So x minus 4 over x minus 3 is our final answer. Okay, we're under a second example. Please see if you can find the factors of the numerator and the denominator, then cancel out the like factors. Looking at the numerator, you notice they have 2x in common, so we can factor out 2x, leaving us with 2x minus 1. On the bottom, you'll notice they both have 6x in common, so we can factor out 6x, leaving us with 1x minus 2. So then we look at inside the parentheses. We cannot reduce 2x minus 1 and x minus 2 because they are not the same. We look at the 2x and the 6x, and yes, 2x and 6x are factors of the numerator and denominator. That means that we can reduce the 2x and the 6x. So we can cross out the x's in this case because they're linked to the parentheses and the 6, the parentheses and the 2 by multiplication. We can also reduce 2 and 6, giving us 1 over 3. In the end, this leaves us with 2x minus 1, and we distribute that 3 that's left over, and we get 3x minus 6. My question to you again is, can you reduce the x on top and the x on bottom? The answer is no, because x is not a factor of the entire top. 2x minus 1 cannot be factored further, and 3x minus 6 cannot be factored further by an x either. So there are no common factors top and bottom anymore, which means this is our final answer. Okay, I have a couple of examples for you to try on your own. Please pause the video and press play when you're ready to see the answer. Okay, I've gone ahead and factored the expressions for you. What we're going to do now is we're going to cancel out like factors on top and on bottom. We notice top and bottom of the first expression has an x plus 1 and an x plus 1. So we can cross those out, leaving us with x minus 3 over x minus 1. The second expression, you notice both the top and bottom had common factors, so we could factor out the 4x, leaving us with x squared minus 25. And on the bottom we could factor out 3x squared, leaving us with x plus 5. X squared minus 25 was a difference of 2 squared, so we could factor that as x plus 5 and x minus 5. We notice there's an x plus 5 on both top and bottom, so we cross those out. And we look at the 4 and 3. There are no common factors, but if you look at the x and the x squared, this is x to the first. We can cross out one of the x's out of both top and bottom, leaving us with 4x minus 5 over 3x. You still need to distribute your 4, leaving us with 4x minus 20 over 3x. And that's your final answer for these two examples. We have two more examples before we get to our last objective that will demonstrate one more important concept for reducing rational expressions. And we're going to go ahead and see those right now. Okay, go ahead and try to find the common factors and reduce these two fractions. For the first fraction, you might have been tempted to say they have no common factors because they're real similar, but they're not exactly the same. X minus 3, 3 minus x. This one's a tricky one, and that's why I wanted you to see it first on the video before you practice any problems containing this type of problem. X minus 3, if we factor a negative 1 out of the denominator, we'll get x minus 3 over negative 1, negative 3 plus x, which is the same thing as x minus 3 over negative 1, x minus 3. What's tricky about this one, I'm going to put parentheses around the x minus 3 on top, just to point out that x minus 3 is the factor of the top. Again, what's tricky about this is that it didn't look the same at first, but we can make it the same by factoring out a negative 1, which allows us to cancel out the top and bottom, leaving us with an understood 1 in front of that parentheses. So 1 over negative 1, which is negative 1. This is a bit tricky. If you want to, you can just memorize that if the expressions are almost the same, but the order's different, like x minus 3, 3 minus x, and they're separated by a minus sign, then you can just factor them out to get a negative 1. Let's use the second example to demonstrate that point. Top, they're divisible by 4, leaving us with y minus 2. The bottom is divisible by 6, leaving us with 2 minus y. We can reduce the 4 and 6, giving us 2 over 3. And just like the previous problem, we notice that y minus 2 and 2 minus y are the same, except the order is different and they're separated by a minus sign. So we can make that a negative 1, giving us in the end negative 2/3.